My name is Dr. Rambabu, working as an associate professor in the Department of Electronics and Communication Engineering. I am from B.V. Raju Institute of Technology, Narsapur. Course name is Microprocessors and Microcontrollers, and our today's topic is pin diagram of 8086 microprocessor. Before we are going to talk about the pin diagram of 8086 microprocessor, let's talk about the pin diagram of 8086 microprocessor. Mainly to understand the physical layout, pin configuration of 8086 microprocessor, to analyze functions of various pins, to differentiate between minimum mode and maximum mode operations, to apply knowledge of the pin configuration to interface external devices with the 8086 microprocessor. These are all the learning objectives of today's topic. Now, here we already discussed in the previous sessions. Our processor is 8086 microprocessor. This is invented by Intel company. This is a 8086 microprocessor. This is the HMOS microprocessor. In 8086 microprocessor, totally it contains 40 pins. Those 40 pins are available in the form of DIP. Here the DIP stands for dual inline package. Dual inline package means both sides this having the pins. The pins are configured in both sides. Before we are going to talk about each and every pin function, first we will discuss about the classification of pin diagram. The total available pins of 8086 microprocessor mainly classified into three different groups: common function signals, minimum mode signals, and maximum mode signals. Again, these 40 pins of 8086 microprocessor, some pins are address lines, some pins are data lines, some pins are control lines, some pins are power supply and ground and other pins. These are all the pins available in 8086 microprocessor. Now, we are going to discuss each and every pin function. This is the 8086 microprocessor pin diagram. In this pin diagram, totally 8086 microprocessor contains the 40 pins. Here, this one is the pin starting pin and this is the ending pin. Totally, this pin diagram of 8086 microprocessor contains the 40 pins. This side is having the 20 pins, and other side of the this pin diagram, this is having the 20 pins. That's what here we are calling, this is the DIP package, dual inline package. Now, we are going to discuss one by one pin here. If you can observe, the pin diagram of 8086 microprocessor, totally I already told you, these some pins are common function signals, some pins are maximum mode pins, some pins are minimum mode pins. Here, pin 1 to pin 23 and 30 and 32 to 40. These pins are usually we can call as the common pins. But the only difference is from pin 24 to pin 31. These pins will change from the minimum mode to maximum mode and maximum mode to minimum mode. Here, for example, if you can operate our 8086 microprocessor in maximum mode operation, the pin 24 to 31, these pins are available like QS1, QS0, S0, S1, S2, lock, RQ, GT, RQ, GT, not at this. These are all the pins. If we operate this 8086 microprocessor in minimum mode, these pins are replaced with the INTA, ALE, DEN bar, DT by R bar, M by IQ bar, WR bar, HLDA, hold. These are all the pins replaced with the existing pins. In that way, the 8086 microprocessor is going to operate in two different modes. One mode is minimum mode for minimum mode operation, and another mode is for maximum mode operation. Now, first we are going to start with the pins. For the first pin, here we are showing that pin 1 and pin 20, these pins act as a ground pins. And pin 19, these pins act as a clock pin. For this, the duty cycle here, the 8086 microprocessor maintains, that is the 33% of the duty cycle that is maintained by the 8086 microprocessor. For the clocking operations, here we have to connect our 808 microprocessor for the 19th pin here. Next, for each and every processor or controller, there must be a operating voltage. There must, each and every microprocessor, definitely those will work with the some operating voltage only. Here the VCC pin, here we are using as a power supply pin. Here usually we are using the plus 5 volts. 5 volts is the operating voltage for 8086 microprocessor. To connect the power supply, here we are using the pin, that is the 40th pin, that is acting as a VCC, that is the power supply pin. Next, the pin is the pin 21. This is the reset pin. Here to reset the registers, to reset the segment register, to reset the flag register, there is a pin is available in 808 microprocessor. That pin is called the reset pin. Now, here I already told you in 808 microprocessor, some pins are address lines, some pins are data lines, some pins are control lines, some pins are power supply and ground lines. We already discussed the ground pins and the power supply pin. Let's talk about the address and data lines. Now, pin 2 to pin 16 and pin 39. These pins are acting as the multiplexed address and data lines. If you can see pin 2 to pin 16, that is the AD0 to AD15, and 39th pin is the AD15th pin. These address and data lines are multiplexed here. For example, if you can operate, if you want to use these pins from the pin 2 to 16 and 39th pins as a address lines, there is a one more pin is available in 8086 microprocessor. That is pin is called the ALE. ALE is the address latch enable. If you can make address latch enable pin is equal to 1, this AD0 to AD15 acts as the A0 to A15 address lines. Suppose if you want to use this AD0 to AD15 piece for the data operations, we have to make ALE of ALE pin must be, that is in the mode like 0. We have to keep ALE is equal to 0. Then AD0 to AD15, these lines are acting as the data lines. In that way, by using the address and latch enable pin, these multiplexed address and data lines we are going to use for address operation, for the data operation. Next, in this some pins are in the out of this 40 pins, some pins are interrupt related pins. Those pins are pin 17th pin, pin 18 and pin 24. These pins are acting as a interrupt pins for interrupt related operation. For interrupt related operation. Here pin 70 is the non-maskable interrupt operation. And for if any interrupt is requested from the outside, the pin must be that thing that must be connected to the 18th pin, that is called the interrupt request pin. After execution of the interrupt, to give the acknowledgement, there is a one more interrupt pin is available in 808 microprocessor. That pin is called the interrupt acknowledgement pin. Totally 3 interrupt related pins are available. Non-maskable interrupt operation, that is a MMI pin is available. For interrupt request operation, that is the INTR pin is available. For interrupt acknowledgement operation, that is the INTA pin is available in 8086 microprocessor. At the same time, to speed up the data transfer operation in 8086 microprocessor, there is a operation like direct memory access. To use this, by using this direct memory access operation, without intervention of the microprocessor, you can able to transfer the data between the peripherals. For that, to perform that, there are 2 pins are available, that is the pin 30 and pin 31. These 2 pins are direct memory access. In short form, here we are calling as the DMA. That is the pin 30th pin is the hold acknowledgement pin and pin 31 is the hold pin. These 2 pins usually here we are using for the DMA operation. Next, in 8086 microprocessor, totally that is having the 20 address lines are available and 16 data lines are available. We already discussed A0 to A15 address lines, and the remaining address lines are A16 to A19. Here those are placed at the pin 35 to pin 38. These pins are remaining address lines. Again, these address lines are multiplexed with some status pins like S6, S5, S4 and S3. These are all the remaining higher, usually we can call as the higher address lines here. Here, for example, if we can make always S6 pin, here we are making is the logic 0 only. And S5 is the another status pin. Here we are using to indicate the condition of the IF flag, that is interrupt flag bit. To know the condition of the interrupt flag bit, here we are using the S5 pin. Here S3 and S4. Here we are using to select the segments here. We already discussed in the previous session. Totally 808 microprocessor, there is the 1 MB memory space is available. We can divide the total 1 MB into equivalent logical segments. Out of 16 segments, 4 segments are defined. One is the data segment, extra segment, code segment and stack segment. To select any one of the segment, there are two pins, status pins are available. One is the S3, another one is the S4. If we can make 00, S3 and S4 00, extra segment will be selected. 64 KB of extra segment. If you can make 01, S3, S4 stack segment selected. And if you can make 10, S3, S4 code segment is selected or no segment is selected. For example, if you can make 11, the data segment of 64 KB can be selected for the operation. In that way, the pin 35, 36, 37, 38 pins are used for the 8086 operation, 8086 microprocessor operations. Here some more other pins are available for 8086 microprocessor for the bus high enable. Here if you can take, we already know 8086 microprocessor contain the totally 16 data lines are available. That we are representing those 16 lines, data lines are D0 to D15. Usually we can call D0 to D7 are the lower data lines, D8 to D15 are the higher data lines. To select the D8 to D15 higher data lines, here we are using the pin called bus high enable pin. And there is also one more pin is multiplexed with bus high enable. That pin is called the S7, another status signal. Here this not only for this higher data line selection, sometimes this BHE bus high enable signal, bus high enable pin, we can use for the memory bank operation. If you can make by using the combination, by combining with the BHE and A0. A0 is the another one of the address line in 8086 microprocessor. These two act as a selection and for the memory related operation. If you can make 00, the whole word operation, that means the for 16-bit data transferring operation, we have to make 00 for the BHE and A0. For 01, high byte 2 are from the odd address. I already told you in the last session, the total 1 MB memory space that is divided into even bank and odd bank. We can able to access the data from the even bank addresses. We can able to access the data from the odd bank addresses also. Here 10, if you can make BHE and A0, low byte selected from the even bank, that is the even addresses. For example, if you want no selection for the no operation, we are going to make BHE and A0 signal, that is the 1 and 1. Next, here we can able to operate our 8086 microprocessor in two different modes. One mode is called the maximum mode operation. Another mode is called the minimum mode operation. And how to select this minimum mode and maximum mode? There is a pin is available in 8086 microprocessor. That pin is called the 33 pin, MN/MX bar. If we can make MN/MX bar is equal to that is the plus 5 volts or that is the logic 1, we can able to operate our 8086 microprocessor in minimum mode. If we can make MN/MX bar is equal to 0 volts or logic 0, we can able to operate our 8086 microprocessor in maximum mode operation. And this pin 24 to 31 from int A to hold, these pins are acting as the minimum mode pins. When we are operating 33rd pin, that is the plus 5 volts or logic 1. When we are making mn/mx bar is equal to 0 volts or logic 1, here we can able to operate our 808 microprocessor in max mode operation by using this QS1 to the RQ or by GT0 pin here. In that way, you can able to operate our 808 microprocessor for minimum mode operation and maximum mode operation. Now, let's talk about minimum mode pins. Next, we are going to discuss about the maximum mode pins. At pin 32, this pin acting as a read signal for the reading or writing operation. Here we are going to use the pin is called, that is the RD bar. Here RD bar is the active low pin. Whenever going to make 0, this is enabled. RD bar is equal to 1. That RD bar pin can be, that will be in disable for the disable operation we are using. In that way, we are going to use the RD bar pin. Similarly, one more pin is available, 29th pin. This is for the for writing operation. If you can make WR bar pin is equal to 0, we can able to enable this WR bar pin writing operation. For disabling, we are making WR bar is equal to 1. In that way, the active low pins, for enabling, we have to give 0. For disabling, we have to give, that is the 1 here. And for to operate our 808 microprocessor, for memory operation or input-output operation, there is a pin is available. That pin is called the 28th pin, M/IO bar pin. If we can make a M/IO bar pin is equal to 1 means, we are using 808 microprocessor for the memory related operation. If we can make this is 0, that means we are using 8086 microprocessor for the input output operation. In that way, we are using the M/IO bar pin. And for the data transmission and for the data reception, data for receiving operation, there is a one more pin is available, that is called the 27th pin. If we can make DT by R bar is equal to 1 means, we are using 808 microprocessor to transmit the data. DT by R bar is equal to 0. We are using 808 microprocessor for the receiving data. In that way, we are using the 27th pin. And this is the data bus enable. We are having the data lines are from the D0 to D15. D0 to D15 data lines can also call the data bus. To enable the data bus, there is a pin is available, DEN bar. Similarly, this is also active low pins. If you can make the DEN bar is equal to 0, this pin can be enabled for the operation. Next, the pins available, the status pin, remaining status signals are S0, S1 and S2. This S0, S1 and S2, these pins belongs to the maximum mode operation. By giving the binary combination of inputs to S0 and S1 and S2, we can able to operate our 808 microprocessor for the maximum mode operation. If we can make 0, 0, 0, we are using our 808 microprocessor for the interrupt acknowledgement operation. For 0, 0, 1, read IO port operation. 0, 1, 0, write IO port operation. To halt the processor, there is we have to give 0, 1, 1. For the code accessing, we have to give the status signals are the 1, 0, 0. For the read memory, we have to give 1, 0, 1. For write memory, we have to give 1, 1, 0. For the non-passive operation, here we have to give the 1, 1, 1 for the in the max mode operation. In that way, by giving the binary combination of the inputs to the 808 microprocessor, we can able to get the maximum operations in the maximum mode condition. Next, pin 30 and pin 31. These two pins here we are using for the DMA request or grant operation. We are using the DMA without intervention of the microprocessor to speed up the data transferring. There we are going to give the condition, that is accessing of the data bus and control bus and address bus to grant the access. Here we are going to use two pins. Those two pins are RQGT0 and RQGT1. These two pins here we are using to request or grant the system bus. System bus nothing but address bus, data bus and control bus. To grant or that is the request these particular buses, here we are going to use the pins called the RQGT0, RQGT1. These two pins here we are using for this operation. Next one is to lock the peripherals. To lock the peripherals, there is one more pin is available. That pin is called the 29th pin, that is the lock bar pin. Here we are using this lock pin used to lock the peripherals of the system. And this can be activated by using the signal, like we have to give the lock, that is the prefix of the any of the instruction. We are going to give lock and next we are going to give the instruction. In that way we are going to lock the some of the peripherals in 8086 microprocessor. Next one is the QS1 and QS0. These two pins here we are using in the coprocessor mode. Here we are, for example, if you can give 0, 0, the Q is in idle condition. If you can give 0, 1, first byte of the, to access the first byte of the opcode. And 1, 0, the Q is empty. And 1, 1 is subsequent byte of the opcode. Further, in the coprocessor mode operation, here we are going to use these two pins, QS0 and QS1. The next pin is the test pin. The test pin here we are using when the signal is high. When this test pin is equal to 1, then the processor has to wait for the idle state. Else, the execution continues. In that way, we are going to use the test pin. And the next important pin is the last pin is that is the ready pin. Whenever we are going to activate or whenever this is the active high signal, that indicates when the device is ready to transfer the data. When the microprocessor is ready to transfer the data, then we have to give READY pin is equal to 1. Then you can able to transfer the data from the microprocessor to any of the peripheral devices. And this is about our pin description. Now, after learning all the pins functions of the 8086 microprocessor, student can able to identify and describe the purpose of each pin in 8086 microprocessor. Students will be able to how the microprocessor operates in minimum mode and maximum modes using the appropriate pin configuration. And students can able to analyze the role of key control and the data pins in managing communication between the processor and peripheral devices. This is another objective. And student can able to demonstrate the use of the 8086 pin configuration for designing interfacing circuits in practical application. These are all the learning outcomes of the pin diagram in 8086 microprocessor. This is about the pin diagram of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.